Hello everyone, we go over group quiz 4. The first question is about 95% confidence interval for the difference in the proportion of males in India between 1901 to 1981. So you will see that you need to compare two proportions from two different years for males. And this is about intervals, so it's 2 prob z interval. So that's going to be the calculator command that you are going to use. So it's good that you write it as soon as you realize, because it's going to give you direction on what you need to do. So then you input it in the calculator. So the number of males in 1901 is 103, so that's x1. And then N1 is the total of people that they surveyed. So they surveyed 203 males and females together. So you need to put the total as 203. X2 is 107, number of males in 1981. And then out of the total of 207 males and females that they surveyed. And then for the confidence level, of course, you just put 0.95. So I don't want you to check normality for this quiz. We have practiced that many times, so I assume that you know that how to do it. 0.11 going all the way to 0.09. So, and remember that this is the difference of P1 and P2, the difference of proportions in 1901 to 1981, the true population proportion as of the differences of the two. If you notice, 0 is in between the two values. So if you think of number line, so negative 0.11 and positive 0.09, 0 is in the middle. But there is a possibility that that's equal to 0. So we said in the past that if we have P1 minus P2 equal to 0, so that means there is no difference between the two proportions. So here is the conclusion. We would say we are 95% confident that the true population proportion of males in India is the same between the years 1901 to 1981. Use the word population proportion. I'm just writing it. Okay, the next question. So you're comparing two population proportion again on the next one. So for the next one is a test, and you are comparing, it says, do these data provide sufficient evidence to conclude that the proportion of athletic people who eat Wheaties is less than the proportion of non-athletic people who eat Wheaties, and use the 10% significance level. So they gave you set of data about athletic people and non-athletic people who eat Wheaties. And they want to just know if there is any difference. And then they gave you the 10% significance level. So what you need to do, this is a test, is different than interval. So you will note yourself that I know that this is going to be 2-prob z-test. But before running the test, you need to write the null hypothesis, alternative hypothesis. Null hypothesis is P1. Always you assume that the two proportions, the two population proportions are the same for athletic and non-athletic people. And then alternative is what's the claim. So it says that the athletic eat less of Wheaties compared to non-athletic. So if P1 is for athletic, so P1 is less than P2. Step 2 is checking the normality. Again, I assume that you all know how to do it. It's n times P1 greater than 10, n times 1 minus P1 greater than or equal to 10, n times P2 greater than or equal to 10, n times 1 minus P2 is greater than or equal to 10. Okay, step 3. Step 3 says find a p-value. So you use 2-prob z-test. You tell me what you put into your calculator as far as x1, n1, n2, x2, n2. So you enter them into your calculator based on what you have. X1 is 48, N1 is 300, X2 is 52 out of 200, and then you will use the one that says less than, because P1 is less than P2. The p-value is equal to 0.003. Okay, that's definitely less than 10%. So we reject a null. And we support the alternative hypothesis. So step 4, you'll be writing the conclusion. So you would say there is enough evidence to support the claim that the proportion of athletic people who eat Wheaties is less than the proportion of non-athletic people who eat Wheaties. Okay, going to the next question. A sample of 10 mothers and their firstborn daughters were asked their heights. And here is the info. You want to find a correlation coefficient. You would put that in L1, the first set in L1, the second set in L2. If you were graphing this one, which I didn't ask you for the scatter plot here, but let's imagine that you go from 60 to 70 in this direction, and you're going 60 to 70 in this direction, and plotting the points. So 67, 67 would be a point probably if this is 66, 67, 68, 69. Let's say 67, 67. That's a point there. 69, 71. That's a point a little bit higher. 67, 68. Just a little bit higher. 65, 65. 66, 66. 62, 61. 66, 67. 63, 62. 61, 59. 66, 66. I'm going to be on top of that. So as you see, if I was passing a line through this one, this is a very close correlation here. So it should be a number that is very close to 1. And then you put it to your calculator, you say L1, L2, and then you go to Stat, Calc, and you're going to tell me what you are using. And number 5 is line regression. So when you use that, you get R equal to 0.99, as you were expecting, a close number to 1, because it's very close relationship. And what does the correlation coefficient say about the strength of the relationship? You would say there is a strong relationship between, I want you to write it with the context of the problem, between the mothers and daughters' heights. Okay. So there's a strong relationship between the mother's and daughter's height, and I want you to write that as a complete sentence here.